The range that you had before.
Yep. So select everything from A1 to B56. And now we go on data and sort. So that's the simplest way, right? So if we're changing now the column, so with sorting, you can change the respective column your sorting is based on. And if you do that, you can essentially define which column you want to sort on. If you go on count and do the smallest to largest, it will basically sort your data and give you the lowest value first. So all you need to do now is essentially you're just counting. And we see that this goes until 15. So if we have a row, so 15 minus 1 is 14. So we know now that the number of countries with one volcano is 14. That's the simple way. That's a very basic way, and we could do the same with 2, for example. So we could just count the 2s. So this is now now you need to calculate it manually. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now hypothetically I could just write the number in. But we want to do this a little bit more sophisticated. And there's a function in Excel that is called COUNTIF. COUNTIF, you remember from last time, we used the if function. We said like, give us a 1 when the Stroop test time to completion was greater than 15. So we did if that cell is greater than 15, then give us a 1, otherwise give us a 0. So now we're doing something comparable. Now we do count if, and you see already it automatically pops up. So it gives you already as an option count if, and everything you need to do, you just click up there, you make a parenthesis, and now it tells you up here. So you want to give Excel a range, and you want to give it a criterion. And if you're interested in a range and a criterion, the range is clear, right? The range is still B2 to B56. The criterion here is 2, because we want to count the entries that are 2. Now we just need to close this, and we're getting now the number of entries that are 2. Simple. It's a very Yep. So I'm gonna copy it on the side that you can trace the formula back. So it's simple, right? Count if with the range, separate by comma from the criterion, and the criterion is 2. So now you can go a step further. And this is, you remember how we discussed last time, soft coding and hard coding. Hard coding is when you do exactly that. You're saying count if, you give it a range, and you're saying 2. I'm interested in 2. So now you can also quote unquote soft code it. And if you soft code it, you can utilize your time series here on the left, and you say, okay, reference the criterion here from the left. Go to the left, take that value and compare that range that I give you to that value to the left. So the formula that I'm discussing here is count if B2 to B56, and the criterion here is H4. Gives us 4 volcanoes. So it basically will over. So basically what it does, it's the same formula as the formula above, but it changes the criterion of 2. It changes it to H4, which is this value here. Simple. And now continue thinking about it. You remember from last time, and I will repeat that today, that we locked in a cell with a $sign. Because if we would go on now Hypothetically, you can use this formula for all these entries. So if I change H4 to H5 to this formula, it would automatically query 4. And I could do that by just pulling this formula down here. The problem if I do that is that Excel will automatically shift not only the criterion, but will also shift the range. So it's now B3 to B56, which doesn't help us because we want B2 to B56. Make sense? Everybody with me? It's logical, right? It's kind of very intuitive. So we need to manipulate this formula in a way that it's locking that range in. And we're doing that with the $sign. So with the $sign, you basically you lock in that reference range, and you're locking in first the column B, then you lock in the cell, the row 2. You do the same with the B56, and you have $B, $2, column, $B, $56. That's how you lock in a range. But what you don't want to lock in is the criterion, because the criterion you want to shift down and the line with all the entries in column H. That way, you have this shifting criterion with each line you're pulling this down. Because if I'm doing this now, I get now all the entries down to 17 without having to do any additional work. So basically I've saved myself now at least 30 minutes of time to count this through. Yes.
You don't have to put H4 or put them just right.
It would need to be H4 because you want to refer to the respective cell. So the H4, yeah.
Before you just put 2. What's the difference between the first?
Well, that this was just I approached it stepwise to guide you through this process to essentially determine H4. So this is counted. This is by hard coding 2, and this is soft coding the 3. Yeah. Yes. You can, if you would have started this earlier. So now I have here a functioning formula. I can drag this up. Oops. Not this one. This one. No. I didn't look this one in. So if I'm doing this formula right, and I have here $B and $56. Correct. The $sign essentially will now allow you to move this formula around, and it will be the same also for these up there. So I have now overwritten the old 14 that I manually entered. I've overwritten it with that formula, gives me the same result. So that's thereby it confirms I counted correctly.
But you write $signs because
it's locking it in. So it's not shifting it when you go down. Whereas it does shift the criterion, and it takes the respective criterion in the line. Yeah?
Yes.
Okay, great. Yes, please. Agar. Which one? Oh, the counting is easy. You go on A1 to B56. You go on data, sort, and you choose here the column count. And then you sort it by smallest to largest. But make sure that my list has headers is clicked. That's how you sort it. Yeah.
Then you do it again by country so that it goes back to you.
If you would sort it by countries, it goes back to an alphabetical order. Yes. Yes, please.
If I don't put a $sign,
Then it will shift the range.
but I didn't put a $sign for that third one, for the for like piece.
Yeah.
4, and it still works.
No, it doesn't, because it's counting the wrong range.
But I have the same number.
Well, probably not the next one. If you
No, I didn't go down.
Hmm?
Like I drag it down and I filled it.
You have the exact same numbers as I do?
Yeah.
You sure?
Yeah, but I only started filling it from each board.
Well, then it's a coincidence that it kind of shifted in a way that it's still counting the same. But it's not the correct approach.
Like, how do you have it written? It wouldn't work.
Like this, that is the correct formula that you could use for whatever data frame you're looking at.
So what I have is when I click on the cells, it shows them each individually for like H5, H6, like it all it's in the order.
But the range has changed.
Oh yeah, the range did change, but it's still the same number. It just-
Well, that's a coincidence though. But it's formally wrong because you're counting it from a different range, a shifted range. So then it's a coincidence, it's the same number.
You have dollars for every number.
No, you're just putting it in front of the column, which is B,
Uh-huh.
and in front of the row, which is here 2, and then 56. Yep, that's how you lock it in. Yes, please. Another question? No? Okay. All right. So it's simple, right? It's not really that complicated when you think it through. It's easily doable, but you will have situations where this can be super helpful, and I leave it to your imagination what this purpose could be, but it is a very useful function in many accounts. Good. So you have now essentially an overview of the number of countries with a certain number of volcanoes. And so we have completed exactly that exercise. So we have now that frequency table. And that is the first step to actually complete such a frequency table. And that's the first step to aggregate data in a way that you can communicate it to an audience or a colleague or whatsoever, or whomever. So now as a next step, you have a certain number of countries and you want to calculate a percentage of countries from your overall collective that has a certain number of volcanoes contained, right? So we all remember, hopefully from high school, how to calculate percentages. That's super simple. And move this over there. So if we want to calculate now a percentage, how is a percentage calculated? It's basically the smaller part multiplied by 100 divided by the number of the entire pool. So if you want to calculate the number of or the percentage, you basically have to take the number of countries in the respective cell you're interested in, and you have to multiply it by 100 and divide it by the overall number of countries in that table. Also in this context, and I'm flagging this as a quiz question, know the difference between a proportion and a percentage. A proportion is the respective number of countries, so that's 14 divided by the sum of all these countries, by the number of all the countries, not multiplying it by 100. Only if you multiply a proportion by 100, you get a percentage. So know the difference. So proportion is this, right? Okay, firstly, you want to calculate, so you want to know how many countries are in there. So you basically, the proportion would be 14 divided by the number of countries that are depicted in your table. So this would be sum of I2 to I18. That's just summing all these countries up. So that's the overall pool. And then you take the smaller part divided by the number of countries. And that is here 0.24. Huh? Ah. So it's taking the overall collective. Okay, let's do this different. So it's not just the table, it's basically count of B2 to B56. Huh? What are the capital anymore? Oh, okay, 27.45. Okay, they have one as the last. We have one as the first. Okay, so maybe it is the table then. So it's sum I2 to I 18. Okay, so it's 27.54. So this is consistent with what Norton and Heinzen have here. They just have it organized differently. So the difference between the proportion and the percentages, it's 0.2745. That's the proportion. So you have a maximum of 1. And the proportion is the fraction of this overall pool of countries, which is as a collective 1. So the fraction of that is your proportion. Yes, please. Min and max. The formula is right next.
Is it 82?
81 is the max. Yes. The formula is in the column right next.
No, but like, and then the second formula you use for L. Like, are you getting the country percentage?
No. The L is calculated. You mean the J? You mean this one?
Like, how am I getting the percentage?
Okay, so this is the proportion. So the proportion is you take the respective entry. You take the respective entry. So you take I2, this entry, which is 14 countries, and you're dividing it by the sum of all countries. So it's the smaller part, the subset of those countries that contain one volcano. 14 out of a total of, I don't know how many countries these are. Some of this. So it's a total of 51 countries. So 14 out of 51 countries is 0.27 as a proportion. And if you want a percentage, you just have to multiply this by 100. That's a percentage now. So 14 is 27.45% of 51 countries. That's how you calculate proportions and percentages. Okay? Yes.
How can you just multiply it?
Multiplication is done with the asterisk. So this is the asterisk is to be found with Shift 8. So if we click now here, so this is J2, the proportion multiplied by 100 gives you the percentage. Yeah.
So should I just wrap it to the dollar sign again? Or would it?
Yes, we need to do another dollar sign. Good question. Because if you want to track this down, you will need to lock in the sum, because otherwise it's shifting the sum, right? So if I'm shifting, if I'm locking in the sum, I get $I, $2, colon, $I, $18. If I want to track this all the way down, I basically get now this overview. If I want to calculate the percentage, I just need to drag it down. So the percentage here, because you're only multiplying aligned that respective entry to the left, you're basically multiplying this by 100, aligned with whatever you have written in the column right next to it. Yes.
Proportion thing is not working.
The proportion is not good.
I did equals, then you said 12, so
14. So if
I'm
you,
doing it by number, I'm doing it by the second country.
okay,
So I would
you-
12 then, no?
yeah, it would be I3 divided by the sum of I2 to I18. Yeah. But make sure to lock this in and make this with dollar sign, you're locking this in. So it needs to be $I, $2 to $I, $18. That's the simplest approach, because now you can just go back and forth and you can overwrite the formula and it will not shift that range. Super helpful. Yes, you got a question? Oh. Okay. All right. So this is really excellent one-on-one. So this is really the basics. And this is super important because we will have formulae like that quite often. And it's useful to know it. Just trust me, please, on that.
Do we need to know for like the exam, like how to do certain things on
You will not be, well, you will need Excel likely to do some calculations, some simple calculations. You will not be asked to do whatever tabulation. Don't worry. You will have to do it for the homework. Though. So the homework, it will be helpful if you understand the formula right now that you can complete the homework, but it's not going to be very hard. Yes. Yeah. So you basically you enter I2 divided by the sum of $I, $2. So this formula here, right? I2 divided by the sum of $I, $2 to I, $18. That gives you the respective proportion aligned with the respective value to the left. So it will shift your smaller part, your subset, and it will divide it by the constant sum of all the countries involved. Yep. Good. So now what's interesting, so we have here 51 countries. So we're building here the sum of all the countries. And if we're dragging this all to the right, and that's the beauty of a percentage and a proportion, because the proportion will always sum up to 1. And the percentage will always sum up to 100. Has to, right? So that's the arithmetic principle of calculating proportions and percentages. So these are the formulae, and these can be used to reproduce the example. Just highlighting this. So what you have here in essence is already nothing else but your frequency table. So you can utilize this frequency table to copy it in your paper, in your thesis, in your essays, wherever you want to put it. You can make this an actual table. If you go on format cells, if you select a certain part of your spreadsheet, you can make a right click on it and you go on format cells. If you go on format cells and you click on border, you can actually make this a border and make this a proper. So you can build a framework around it. That looks a bit more like a table. So that's how it looks like a table, right? What you also can do, you can format the actual numbers that you see. So if you want a proportion, I think it's kind of good to present proportions. If you go on format cells, you can click on number, and you can change by clicking on number. You can put 4 decimal places here. So you see here 4 different decimal places. If you want to format this even less, you can go on number and only leave 2 decimal places. Shows you now the percentages with 2 decimals. A right click and go on format cells. So you press Control and you click on it, gets you to format cells. And here you can select the number of decimals. And once you have these decimals, you can customize your numbers as you want to customize them. Good. Okay. Any questions to this exercise? It's considerably simple, right? It's not really that complicated, and gives you a nice little frequency table, understanding the countries that have a certain number of volcanoes in it. Okay. So this is a frequency table. This is a simple frequency table showing you kind of how many countries you're dealing with, and how are these respective number of volcanoes, how are these distributed in all those countries of interest. If you want to go a step further, you can summarize this data even further by basically showing a so-called grouped frequency table. A grouped frequency table is now nothing else but grouping these occurrences. So if you have, let's say, 1 to 5 volcanoes, you're interested in countries that have somewhere between 1 to 5 volcanoes, you can just summarize these. So this essentially how it looks like. So you basically have 0 to 10, 0 to 9, 10 to 19, and we're going to do this next. And this is a little bit more involved. Okay. This is a little bit more involved because it will require for you now to determine interval sizes. So Nolan and Heinz said that this was steps of 9, and we're going to do the same thing. And it's considerably simple to do that. It's a little bit more involved than just using count if, but it's basically still the same principle. So what you have to do now, so you have now 0 to 9, 10 to 19, 20 to 29, 30, 39, 40 to 49 with 50 to 59 with 60 to 69, 70 to 79, and we have 80 to 89. So now we want to calculate this, right? Range. And we're going to do something different now. So we're going to do min, max. We're going to do count. Why do we do min and max? Because there's a reason to that. So we have 0, we have 10, we have 20. And here we have 9, 19, and 29. What we can do now to complete this, we're just selecting this and we're utilizing the fact that Excel is very smart because we're giving it a series. And once there's a series and Excel detects a pattern, Excel will continue the series for us. Which is great, right? Because it saves you a lot of work again. And that is why I'm showing you these things, because it makes your life easier to play around and to understand how Excel thinks. So you basically, if you have min-max, you have now these ranges shown. And now we're going to have an additional formula. Because now we need a minimal entry and a maximal entry. So we need now not a count if, but we need a count ifs. And that's literally how the formula is called. And this is why Excel is so brilliant, because it allows you all these things in a very intuitive way. You just gotta take this little bit of time to follow along. How does that program actually think? How did the people that programmed it think? And if you do count ifs, you have now, let's do this in the so-called formula builder. If you write count ifs and you click here on the left upper hand, you have fx. That is a clarification of the formula. Now you open up here the so-called formula builder. And in the formula builder, you can actually do this in an easier format than just entering it. So if you say the range is now $B, $2, colon, $B, $56, you need to just define a criterion. So the criterion now is greater than 0, right? And you do that by putting quotation marks, greater than 0, quotation mark. If you click now on the plus sign here, you get again the prompt for a range, and you just copy down this range here. You click again on the plus, and you get here quotation mark, smaller than 10. And so now you see that you have 46 countries that have somewhere between 0 and 9 volcanoes on their soil. And admittedly, this is a rather complicated formula, but it's also a very powerful formula. Because what you can do with this formula, so again, just to repeat, so you have count if $B, $56, $B, $2 to $B, $56 as range 1, then you have criteria 1. Supposedly, it's supposed to be greater than 0. And it's $B, $2 to $B, $56 and smaller than 10. And that calculates from your range and counts all these entries. I will post that spreadsheet so you can revisit the formula and take your time to really kind of like digest it in a way. I know there's a lot of information, I'm well aware. But it's, I'm just meaning with the recording and the Excel spreadsheet, you will be able to get through that. And it's very intuitive. Once you kind of saw what's happening with each respective part of the formula, you will get a handle on this. So what we're gonna do now, we're gonna carry this formula even further. We're gonna carry this formula further by essentially actually, let's not carry it further. Let's just change it manually. So we're doing, so it's greater than 9, it's smaller than 20. That would give us the entries for between 10 to 20. If we do this now for all our entries, because you can go even further and you can kind of automatically take it from that value, but then you need to make it even more complicated. So let's not go this pathway. So if you do here, for example, you do 19, and here you do 30, gives you those entries between 19 and 30. Here you have 29, here you have 40. Here you have 39 and 50. Here you have 49 and 60. Here you have 59 and 70. Here you have 69 and 80. And here you have 79 and 90. And there's only one country that has 81 volcanoes, which is Peoples. So this is our final grouped frequency table, basically defining these ranges. I hesitated, I did not go further to assemble this formula together. But you can do it, but basically you use an ampersand to kind of merge the criteria together. So but I spare you that part. Good, but this is how you would do that. And it's considerably intuitive and allows for you to really facilitate your work to build a frequency table and a grouped frequency table. So that's basically what these two exercises show. And that's basically all you need to essentially aggregate your data in the first step. Any questions on this? I know the formula are quite involved, but I'm sure you're gonna get a handle on it. Yes, please.
Use that formula, the last one, well, last counted one.
Yep. Let me zoom in. It makes all the things a little easier. So count ifs is essentially indicating, as opposed to count if, which only uses one criterion, count ifs will basically define a range which you're locking in with the dollar sign. With a quotation mark greater than 0, it basically gives you a minimal range. So it's greater, it's not greater equal, it's greater. So that means it's at least 1. And then you have with $B, $2 to $B, $56, you basically, you define the range again. And then you have smaller than 10. That means it's from 1 to 9. And with the other formulas, I just did the very same thing. You have the very same thing. So you just, what you do here, you just use a different range. So we have here from 0 to 9, from 1 to 9. We have here from greater than 9, that's 10. From 10, smaller than 20, that's 19. So we're from 10 to 19. And that defines that range and counts all those countries that have an entry consistent with these 2 criteria. Yeah? Yes, please.
And then dollars I got credit in that.
It's no. You need to know which one you want to log in with. So hypothetically, if you do it manually like I did here, and you just copy the actual formula, you're just not allowed to shift the range. So the range would need to be the same range for each of those entries. And if you pull the formula down, then the range shifts. So with the dollar sign, you're locking that range in, and no matter what you do with the formula, it will always be the same range. Okay? All right. Yes. The minimal maximal values like these. So we have 1 and 81.
No, sorry. When you have a range, you have to.
Oh, so it really depends on this definition here. So if you want to define it in that way and you do 0 to 9, 10 to 19, you need to have as the minimal value 10. And the reason, so hypothetically, hypothetically, you can also do it in that way. So you can also say, so this is now greater than 9. Greater than 9, not including 9, is 10, right? So you could hypothetically, you could also rephrase this formula as greater equal 10. For the sake of simplification, I just used greater than 10. So greater equal 10 is the same as greater than 9. Yeah. So that's why I used greater than 9. So that's how you define those groups.
And my question is actually much more simple. In the previous column, when you wrote minimum, and then you have the minimum values, the maximum values.
Yeah.
How did you do that?
That I just put in by hand. That's just by hand. Yes.
To count if and count ifs.
So count if only has one criterion. So with count ifs, I only tell Excel to look at one criterion, which is here. Give me everything that's 2. Or give me everything that is equal to age 3. With count ifs, I provide a range. So I'm counting each entry between 10 to 19. So I have several criteria that define a range of values of interest for the counting. That's the difference. Yeah. Okay, perfect. All right. So as promised, it's a little bit more Excel intensive today, but it comes with a good outcome because now we have our tables together. And I will provide you with the spreadsheet. So I'm going to send you that as an announcement. You will get at the end of the class, you will always get the spreadsheets that you can look and compare to what you did along during the class. and to make sure that you have the correct formula. Good. So this is frequency table and grouped frequency table. If you want to do the next exercise now, let's go back one. If you want to visually depict this now, so we remember the three ways to show frequency distributions: A, the frequency table; B, the grouped frequency table; and C, the histogram. A histogram is essentially nothing else but a bar graph. Bar graph is basically nothing else but bars that indicate some value. In the context of a histogram, this depicts on the y-axis. So you know, in a graph, you have a y-axis, which is the vertical axis. Then you have a horizontal axis, which is the x-axis. The y-axis shows the frequency of the occurrence of each individual value depicted on the x-axis. For our volcanoes, this looks as shown on this graph. So you have one volcano 14 times, two volcanoes 12 times. So you have this depicted in this shape or form, showing you essentially depth distribution. And that's a frequency distribution. That's a visual depiction of a frequency distribution. And if you are now showing this as an actual histogram, you just go back to your Excel spreadsheet, you're selecting your frequency table, and you go on Insert. And now I always have to find this myself because I do not do graphs in Excel, but I will find it. So you basically, you have here a couple of graphs depicted, and you will look for the bar graph, and here you find histogram. So here you get a grouped frequency table. It's not what we wanted. To customize now. Format data series. Overflow bin. So the bins, number of bins, we're changing now to 17 bins. Okay. No, that's not what we want to do. I'm sure that it's not doing what I wanted to do. Yeah, we're gonna do this. Okay, so usually I don't do graphs and or I don't do histograms in Excel. Okay. Overflow bin 24 in with by calendar. Okay, let's keep it automatic for now. I'm gonna owe you that. So we see it only grouped here 1 to 8. Sorry for that. I gotta do my homework before I show that in class. Okay, good. So we're gonna see the histogram then in R. In R, it's easier. Yep. So as said, some things are not as intuitive as I say they are. Okay, so but this is basically, this would have been the outcome, the desired outcome of this exercise. So we're having now a histogram. We have here the y-axis, that's the frequency, and we have on the x-axis we have the number of volcanoes in the respective country. So this is the number of countries with a certain number of volcanoes contained. if you would like to show the grouped frequency table, it's the same exercise. You have now those with 1 to 9 volcanoes, that's the 46. From 10 to 19, you have the respective 4 volcanoes. So that's the grouped frequency table. So you have now the normal distribution and the skewed distribution. You have a specific frequency distribution that is a bell-shaped symmetric unimodal curve is a normal distribution. What does that mean? When you see the distribution of these frequencies, this is not a normal distribution. A normal distribution would be bell-shaped, the shape of a bell, with one peak, and it is symmetric to both sides and equally distributed. This does not qualify as a normal distribution, but it's important to understand the various different kinds of distributions because there's a picture of the normal distribution. So you have a bell-shaped distribution, you have one peak, and you have a symmetric distribution. So again, keep in mind, the y-axis shows you the number of occurrences, whereas the x-axis shows you the possible entries. So you can use methods that show data differently than, for example, here with bars. It shows you as a so-called frequency polygon. That is a smoothed function that basically allows you to show that distribution that is shown here on the left in a smoothed format with just one line. That's a so-called frequency polygon. So again, the normal distribution is characterized by one peak, symmetric, and bell-shaped. And it would, with bars, present pretty much like this. If you have a skewed distribution, and these are the two ways how you basically look at data. You have either you have a normal distribution or you have a skewed distribution. A skewed distribution is characterized by having extreme values that are not symmetric. If you had it on both sides and it would be equally distributed also on the extremes, you had again a normal distribution. But if it's not symmetric and it's skewed, it's pulled in some direction by outliers, by extreme values, you're looking at a skewed distribution. And so here, that's the example. So basically you have a great distribution like that. That would be 0 to 4 is probably a GPA. So you have a distribution that is kind of symmetric. That is a normal distribution. And that would be a skewed distribution that basically points in one direction, and you have outliers and extreme values in one direction. So what is characteristic for the skewed distribution is that you will need to be able to describe them. So normal distributions are simple, right? So they're symmetric, they always have one peak, and they're basically the bell shape. If you have a positive skew, you're referring to that if the skew, the so-called tail, is pointing towards the positive, which is upwards to the right. If you have a negative skew, it's pointing downwards to the negative values. So this being said, you have positive skews and negative skews, which can also be referred to as left skewed or right skewed. So both of these are important to keep in mind when it comes to describing this with the proper terminology. In the very same context, there are also two terms that are important to keep in mind, which is a so-called floor effect and a so-called ceiling effect. What this describes is basically nothing else, but the ceiling effect has a maximal value that cannot be exceeded. classical example, great distribution in a rather easy test. So that's what I want to see on the exams, right? So you basically you cannot reach more than, let's say, 100% or 50 points on the quiz. And most of the students will score very high, and you have some outliers that are pointing to the left, but the ceiling effect says like it cannot be higher than 100%. Whereas the floor effect is the same example, but it starts at 0, so it can't get lower than 0. It can't get lower than a certain value. That's where the ceiling is. That's where the floor is. Sorry. So floor effect and ceiling effect. Classical example for a floor effect is, for example, median household income. Characterizing median household income is like the majority of people are rather on the left end, and the further to the right you get, the less often frequency, the less often households are reporting a household income like that. So these are the different plots. So we have talked about histograms. Histograms show you the distribution. Histograms are characterized by so-called bins. The bins are basically nothing else but the ranges of your grouped frequency table. And these bins can be customized. And that's exactly what I failed with in Excel, because it wouldn't let me customize the bins. And you have then in this frequency distribution, you have a normal distribution, this skewed distribution with a normal distribution. With a normal distribution, you basically have a symmetric bell-shaped unimodal curve. And a skewed distribution, you have outliers or extreme values in one direction. The direction in which those extreme values are to be found, that determines the name of this distribution. So skewed distribution that is left-tailed would have negative pointing towards the negative. Right skewed or positive skewed would be higher values. Then we have distributions of course grades. We talked about that. The tail tells the tail. So the direction in which the tail points, that's how you use, that's the nomenclature you use. You have a floor effect and the ceiling effect, positive skew, negative skew. Then you have a particular way of depicting data, that's a so-called dot plot. A dot plot is basically a plot which shows you individual entries, and each dot will represent one entry in your data set. So if you have, so this is the example that Nolan and Heinzen show here. A dot plot is it's not very common to show dot plots, to be honest. But they're showing you this example, which is mean years of education globally. So you have Argentina to Yemen. You have the number of years students or adolescents in the country have received education, and that varies tremendously between the countries. And you see here the depiction of each individual entry as a dot. It's basically a comparable depiction as a histogram. It's just that each individual country is now represented by a dot. So that's a dot plot. Flagging this as a question of the quiz. Please distinguish between histograms and dot plots. Good, that's all. Any questions? We have 4 more minutes. Let's quickly look into R. Please download the respective R script. What the R script does is it shows you the very same examples. I promised you that each example we're doing in class, you will get provided by me as an R code. And because I think these simple methods, I think there's value that we have to code in case you ever gonna use R sometime down the road. So these examples we're discussing at length in class, and you will have the respective codes to repeat this analysis. So you have here on the code, you have on line 2, you have RM list equals LS. That basically cleans the environment. In case there would be an object here on the right containing data, line number 2 would remove that. Line number 5 basically builds a data frame. These are 55 observations. These 55 observations are basically reflected here. And you have the same data as we have discussed. You can display this by just calling this data frame. We'll show you exactly those entries. You have now DF1 is now basically a subset of those countries with 1 to 17. That is the 52 countries that we essentially used for our analyses. We can now order this data, and that will have now the very same order as we have seen for our Excel spreadsheet. So that's a command for ordering data. With head and tail, you look at the first 6 entries. With tail, you look at the last 6 entries with the highest values. And this line here on line 19 basically creates an empty shell for a frequency table. And with that code here from 21 to 27, you're populating that frequency table and you get exactly the same value as we have seen in Excel. And it basically does the same thing as we did. So now here, that's an example for grades with 2 more minutes. So basically you have the same example. These are grade examples from some exercise in the book. So you basically have here a histogram with the occurrence of grades. And this is again, this shows the bins. And this is what I meant. It's like it's substantially easier to show a histogram here in R because you can much easier customize this histogram. With frequency table, you're basically creating the empty shell again, and then with that for loop that I've shown here, you can easily now build that frequency table. So that's a grouped frequency table that basically depicts the frequency of each occurrence in your data frame. Good, so that's the code for a frequency table. You will not need that for the exam, but I think it's a good code to have because it kind of gives you a good feeling for R in case you want to go deep into R. Thank you very much. Have a nice evening. Thank you. Yes.
Yeah,
Looks okay. Can you stop? Now take a look at the if you go into applications now, you have the installed version of our student.
so then whenever I click on our.
Yeah, but don't click it when you have open our studio first, so click on applications. Go down, our studio. People install R first. First install R. That's R studio.
We lost.
Okay, right.
Doctors at a point, but then like.
Well, that's okay. You need to try this at home, and you need to go through the recording.
But I'm also